Okay, so we're recording third hour today. Have we ever recorded third hour? We have? Okay. So we got to record third hour because I'm gone fourth hour. I'm encouraging kids to go out for any type of spring sport over at Southwest today. So we hope kids get involved. Tractor's going to come along and do that as well. Um, so if you flip to this page right here, so if so Minnie has hers attached, right? If you want to tear it off, you can, or you can have it attached. But we're going to reference that today. I just want you guys to know that we already know these formulas. That's old news. You're not going to do this one, sums of sines and cosines. Area of triangle, we've done. Law of cosines, we've done. Law of sines, we've done. Pythagorean identities, we've done. In fact, the flip side of the page is that kind of expanded in a bunch of different forms. Even odd identities, we talked about that the other day. Remember sine and or cosine and secant, the negatives just disappear. Everything else, the negative comes out front. Today we're going to look at this box. And so it looks like Allie and Shelly have a little pencil pouch. Do you guys have colored pencils in there? Does anybody have colored pencils at your house? Okay, so later on tonight, B Lock is probably going to go home. He's going to start color coding these. Um, you know, some people do that, some people don't, but for some people it helps them remember instead of just looking for the word sum and difference if they like actually make it red. It's like, okay, now I know where I'm headed. So this is what we're going to focus on today. We're going to write down the formulas together. Uh, let's get started. We start by what it's not. Sum and difference formulas for sine. Sine of A plus B. So if you have two angles added together and you're taking the sine of it, some people say, don't write this down, but some people say that it's equal to a sine of A plus the sine of B. And if you say that, that's entirely wrong. It's almost like people distribute the sign as though it's multiplication. 100% false. Um, it's a little bit different than that. Turns out to be this. Sine of A times the cosine of B plus the cosine of A times the sine of B. Right. Thank you for asking, Elise. I was waiting for somebody to ask. You actually have to see the proof here. It's kind of a geometrical proof. It's actually quite complicated. It took me a while to get through, but it was really fun when I did it. If you want to sit down with me after school today, I'll show you how to do the proof. All right, we'll see you. If it was subtraction, you would have subtraction there as well. Okay, so that's a formula that we need to use and recognize. So, if you, oh, here we go. Just saw Jaden in the hallway. Thought she would maybe come and join us third hour, but she's just maybe just getting to school right now. We should make fun of her. Okay. I want you guys to try to understand the purpose of what we're doing. Suppose I have the sine of 45 degrees. Who here knows what the sine of 45 degrees is? Wow. All right. We have about 8 people. Excellent. Very good. Give Elise a round of applause. She got it. She got it. Very good. Very good. Very good. Root 2 over 2. So 45 degrees is pi over 4. But the sine, you have to think of the terminal point. A terminal point of pi over 4, or 45 degrees, if you were to construct that, that terminal point is the root of 2 over 2, root of 2 over 2. And assign the x value or the y value. Sine is the y value. So sine of 45 is root of 2 over 2. Well, using sum and difference formulas, we could calculate some other types of trigonometric values that we maybe didn't know. 45, 60, 30, 90, those are all really nice numbers. Well, what about a situation like this? It says find the exact value of the following. Sine of 23 times the cosine of 67 plus the cosine of 23 times the sine of 67. We don't know the sine or cosine of those values, do we? We have no idea. But it does look like a formula that I just wrote down, namely sine of A times the cosine of B plus the cosine of A times the sine of B. Does everybody agree that it has that form? And we said that that was in fact equal to sine of what? A plus B. So I recognize that it has that form. So all I need to do is sine of, what is angle A? 23 plus angle B, 67. And what is 23 plus 67? 90. What is the sine of 90? It is 1. Very good. Because you located the terminal point for 90 degrees, it's 0, 1. And again, sine is the y value, so you get 1. Excellent work. That's the exact value. And that's the work that I need to see on your test in that situation. Okay? No, as long as you know, however you come up with terminal point, that's fine. Good question. Okay, let's talk about cosine. The cosine formula is a little bit different. Cosine of A plus B happens to be equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. That one's a little bit different. Again, the proof is kind of elegant, but it's fun. It turns out in this situation that if you had subtraction up top, you would have addition on the bottom. And so you're used to writing that plus minus symbol. This is the first time in your life you've probably written a minus plus symbol. Minus plus means that you do the opposite of what was stated. Okay? So we look at this situation here. We got cosine of 2 pi over 3, cosine of 5 pi over 12, plus sine of 2 pi over 3, sine of 5 pi over 12. We wonder what that simplifies to. I don't know, but I do know that it looks like the form cosine of A times the cosine of B plus the sine of A times the sine of B. And we just learned that that's equal to what? Cosine of A, thank you. Is it A minus B or A plus B? It's A minus B. So I have the cosine of, what is angle A? 2 pi over 3 minus 5 pi over 12. I'm going to subtract those. And as I subtract them, I'm going to find common denominators. So it's the cosine of 2 pi over 3 can be rewritten as 8 pi over 12 minus 5 pi over 12. So that's the cosine of what? 3 pi over 12. 3 pi over 12 the same as pi over 4. Pi over 4 is 45 degrees. Did we learn the terminal point for 45 degrees? Sure, we have it right up there. And so therefore, cosine is the x value. The exact value is root of 2 over 2. Not too bad, huh? Don't laugh. You only encourage them. Now they wonder what I'm talking about in the video. Okay, so we move on. You know the sine of 45. You know the sine of 60. You know the sine of 90. You know the sine of 150. You don't know the exact value of sine of 15, do you? We're going to use that sum and difference formula to find the exact value of sine of 15. Sine of, I'm going to write two angles that either add to 15 or subtract to 15 that we know the exact values of. Can you think of two angles that add or subtract 15? Yeah, so you could go 45 minus 30 or 60 minus 45. Either one will work. I'm going to do 45 minus 30 because that's the first one I heard. So again, some people write sine of 45 minus the sine of 30, and that's entirely wrong. Give you hardly any points on the test for that. Instead, we write sine of what? 45 times cosine of 30 plus or minus cosine of 45 sine of 30. Well, I need to know the terminal point for 45 degrees. And you've already determined the terminal point for 45 degrees is root of 2 over 2, root of 2 over 2, right? How about the terminal point for 30 degrees? Pi over 6 is the radian measure. What's the coordinate? Root of 3 over 2, says Carson. 1/2, right? So sine of 45 is what? Root of 2 over 2 times the cosine of 30. Root of 3 over 2, it's the x value, minus, don't swear, that's naughty. Cosine of 45 is the root of 2 over 2 times sine of 30, 1/2. Okay, as I multiply these together, what do I get? Over 4, very good, because you're multiplying, so we will multiply the denominators, minus the root of 2 over 4. And you can see you get the root of 6 minus the root of 2 all over 4. That is the exact value, folks. It says exact. That's the exact radical value. Take out your calculator. I turn my calculator on. I go to mode. I'm making sure that I'm working in degrees. Notice if you type the sine of 30, you already know that you get 1/2. That's a value that we already know. But if you type the sine of 15, notice that 0.2588190451, that's not exactly a value that you were aware of, right? So if we want to be able to come up with a radical expression that's equivalent, here you have it. Square root of 6 minus square root of 2 all over 4. I'm going to check that. Parentheses, square root of 6 minus the square root of 2 all divided by 4. And I've got, there I go. It's the same. I want to be clear. On the test, you write 0.2588. I give you 0 points. Not only that, I take out the red marker and I start drawing things like that. And I get just very, very angry at you, okay? Don't just type into your calculator. Just, it makes me think that you're really lazy. And none of you are lazy, right? Good. Letter B. What's different? Cosine, what else? Fraction, it's in radians. I'm going to convert it to degrees. How do we convert 7 pi over 12 into degrees? Good. Times 180 over pi. Everybody knows that that comes out to be 105 degrees. Good job. So we have the cosine of 105 degrees. Can you think of two angles whose terminal points you know that add or subtract to 105? 1645. Way to go, B. Locke. Cosine of 60 plus 45. Do not do the cosine of 60 plus a cosine of 45. Instead, we do the cosine of 60, then what? Times the cosine of 45. Minus or plus? Minus sine of 60 times sine of 45. Wow, you guys are intelligent. Now, I know the terminal point for 45 degrees, that's root of 2 over 2, root of 2 over 2. But 60, what about 60? What's the terminal point for 60? One half. Root of 3 over 2. Way to go, Shelly. What? Cosine of 60. Is cosine the x value or the y value? X value. Next time you make a mistake, B. Locke, you owe us all $1. Cosine of 45. Root of 2 over 2. Minus sine of 60 is root of 3 over 2 times root of 2 over 2. Wow, you guys are intelligent. Root of 2 minus the root of 6 all over 4. Can somebody tell me, is that going to be positive or negative? It's negative. How do you know it's negative? Yeah, the root of 6 is greater than the root of 2, right? Now, let's just think about that for a second, folks. 105 degrees, which quadrant is that in? Second quadrant, is cosine positive or negative in the second quadrant? It's negative, so it looks like it should end up to be negative. Again, having ways to check your answers, that's just showing you're at a new level for mathematics, which is a great thing. Okay, we have two more problems left. We haven't done tangent yet. Tangent's awesome. Tangent of A plus B. This one works out super simple. Tangent of A plus tangent of B. How do you like that? You love it. Wow, okay. All divided by 1 minus the tangent of A times the tangent of B. So that was just the numerator. That was just the numerator. So you can see same sign in the top, opposite sign in the bottom. So if it's a minus here, it's minus in the top, it's plus in the bottom. That's your formula. Again, you get the formula on that sheet I give to you on the test. That's where we're at. Okay, flip it over. We got these two problems. Find the exact value of tangent of 19 pi over 12. What are we going to do first? Convert it. 19 pi over 12 times 180 divided by pi. Pi's cancel. And 19 times 180 divided by 12, everybody knows is 285 degrees. Good job. So I need two angles that add or subtract at 285 degrees. What do you think? No, they don't have to be right next to each other. You got many options. So fourth hour, we're kind of thinking here. Brain's starting to kick around a little bit. Anybody? All right, I heard one, 225 and 60. I like that. Can you think of another one? $135 and 150? That would work, right? How about 45 and 240? 330 minus 45. 330 and 45. You got all sorts of options, don't you? Can I show you guys which one you should select? Okay, we're going to end up needing to know the tangent of A and the tangent of B, correct? So this is my way to kind of help you. And I know this isn't easy, but I'm going to try to help you work through this. This coordinate right here is 0, I'm sorry, is 1, 0, correct? And this coordinate here is 0, 1. Then we said at 30 degrees is root of 3 over 2, 1/2. Then you have root of 2 over 2, root of 2 over 2. And then you have 1/2 and root of 3 over 2. So is tangent x or y, or what is it? What is tangent? It's y divided by x. So look at 0. Tangent of 0 would be y divided by x would give you 0. Look at 90. Tangent of 90 would be 1 divided by 0, which is undefined, okay? Look at 45. Tangent of 45, you got root of 2 over 2 divided by root of 2 over 2. What do you get? So, if you look at these, here you get 0, here you get undefined, and then here you get 1. So those are all values that we know pretty straightforward, right? But here's the thing. If you choose this one right here, if you choose 30, if you get a 30-degree angle, you get 1/2 over the root of 3 over 2. And if you multiply by 2 over the root of 3, look at what happens. You get 1 over the root of 3, which is the root of 3 over 3. It's not really a nice number, is it? But if you flip that, if you choose a 60-degree angle instead, if it has a 60-degree angle on it instead of that 30-degree angle, then what you have is root of 3 over 2 divided by 1/2, and that comes out to be just the root of 3. Would you rather work with the root of 3 or the root of 3 over 3? Which one would you rather work with? Yeah, so we need to maintain 60-degree angles and not 30-degree angles. So I don't want to use an angle like 150. I don't want to use an angle like 130. So 225 and 60, those are going to work out real nice. So that's what I try to work with. So let's set it up. Tangent of 285 is equal to the tangent of 225 plus 60. We already did some of the work here. How's that going to be written out then? Tangent of what? 225 plus or minus plus tangent of 60. So the top is nice. It's just exactly like what you think it should be. But then you remember what we do in the bottom? Yeah, 1 minus tangent of 225 times the tangent of 60. Sweet. So I know the terminal point for 60, don't I? We already calculated that. The terminal point for 60 was 1/2 root of 3 over 2. And so we said if you take root of 3 over 2 and divide it by 1/2, you in fact get the root of 3. So we know that the tangent of 60 is the root of 3. How about tangent 225? What's the terminal point for 225? Anybody? Terminal point? We got negative root of 2 over 2, negative root of 2 over 2. And so Minnie says we're going to divide those and we get 1. So yeah, the tangent 225 is 1. Good. So let's write it out. Tangent 225 is 1 plus root of 3 over, how about the denominator? 1 minus 1 times the root of 3, which is root of 3, right? Yep. You see how it's nice to have the root of 3 instead of the root of 3 over 3 in that situation? Yeah, makes it a lot nicer. Can I leave a radical in the denominator? No, I can't. Shoot. How do I get rid of a radical in the denominator? Multiply it by what? Very good. When you don't know how to do the math, just do the Spanish. We multiply by the what? Starts with a C, right? Conjugate. Wow, man. Look at you guys go. You guys had your Wheaties today. 1 plus the root of 3. 1 plus the root of 3. Yeah, if you don't know how to do math, just do Spanish. Step up. 1 times 1. 1. 1 times the root of 3 and 1 times the root of 3. 2 roots of 3. Root of 3 times the root of 3. 3. Now I do the denominator. Remember, multiplying by the conjugate, so the middles go away, correct? So I got 1 times 1 is 1. And then negative root of 3, positive root of 3, negative 3. So what do you get in the top? Yeah, 4 plus 2 roots of 3 over negative 2. Are the top two terms divisible by negative 2? Sure are. So negative 2 minus root of 3. Way too fun. Well, look at the last one, example 4. Whoa, whoa! Oh, 4th hour. We had the PTSG, the post-traumatic geometry syndrome, kicking in. You saw the word prove, and all of a sudden you hated life, right? Yeah. No, okay, B-Lock is excited for it. Just do the problem. I like it. The nice thing about proofs, and this one will work out really nice, it's not like the geometry proofs that you're used to doing. The nice thing about proofs is you know the answer. We're supposed to come out with what? Cotangent. So what I have to do is I just have to provide enough evidence between the first statement and the last statement to convince you that the statement is correct. So I'm going to say the tangent of pi over 2 minus u is equal to something. And I know it's going to be at the end. At the end, I'm going to have cotangent, but I got to put something in the middle. So we're going to use what we did today. We've got this whole tangent thing. Isn't tangent equal to something over something? Sine over cosine. So I could write this as the sine of pi over 2 minus u over the cosine of pi over 2 minus u. And by the way, this is what we call cofunction identity. It's one of the identities on your paper. It shows that the tangent is just the cotangent graph, just with a shift and a reflection. which is true. Do we have a way to expand the sign of a difference between angles? What's that? Excellent. So Allie asks a good question. She says, why don't we start with just tangent? The problem is that you would have to find the tangent of pi over 2 or the tangent of 90. And if you do the tangent of 90, notice what do you come up with? An undefined value. And so it doesn't work out the way that we want it to. It creates a problem. You end up with an undefined result over an undefined result, which when you get an undefined result, you got to find another option. I'm going to encourage you to rewrite it in terms of sine and cosine, and that's going to be your best option. Because sine and cosine are never undefined. It works out every time. Let's expand our sine formula. I get the sine of what? Times cosine of u. Plus or minus. Minus cosine of pi over 2 times sine of u over cosine of pi over 2 cosine of u plus sine of pi over 2 sine of u. Everybody good with that? So I've made two statements so far. Does anybody disagree with those two statements? The rest is super, super easy. What's the terminal point for pi over 2? 90 degrees. So what's that coordinate right here? 0, 1. Is cosine the x value or the y value? X. Sine is the y value. So look what you have. What is the sine of pi over 2? The sine of pi over 2 is 1 times the cosine of u. What's the cosine of pi over 2? 0 times the sine of u. Then we have the cosine of pi over 2, which we said was 0 times the cosine of u. And then we have plus the sine of pi over 2, which is 1 times the sine of u. Look at how great that is. 0 times sine, that's going to go away. What are you left with in the numerator? You're just left with cosine of u in the numerator, right? Yeah, cosine of u is in the numerator. What's in the denominator? Sine of u. I wish I knew what cosine over sine was. Oh, wait a minute. Yeah, it's tangent. No, it's not tangent. It's cotangent. Yeah, you are tricking me. Yeah. And then we are done. You just have to decide how you're going to end your proof. Circle it is the result I get. Sometimes people write QED. It's a Latin acronym for that which was to be demonstrated has now been shown. Sometimes people put just a little box at the end. I had a professor, Professor Zorn. Professor Zorn, he wrote the 3 calculus textbooks that we used in college. Really smart guy. He would do a proof and real analysis, and he'd try to figure out how to end it. He'd stand up here, he'd look at it, and his hand would kind of shake back and forth, and he'd kind of be wowing. He's like, what's he going to write? How's he going to end his proof? And finally he'd go, he'd write down and he'd underline it. So, I don't care. However you want to end your proof, go ahead. Just a fun way to say you did it. We won't do that. I got a worksheet for you.